Alright, welcome to today's lesson on threads, where we're going to be talking about how to incorporate multiple threads into one program. So if we think back to the harvester class that we were working on previously, we were trying to come up with the most efficient method possible for harvesting an entire field of things. And what we want to know is there a more efficient way to do it than the previous methods we came up with? And the answer is yes. We can use more than one harvester to do this. If we had one harvester and each harvester had to harvest an individual row, it would then therefore be much more effective. But we have a bit of a problem because all programs, as we know, operate sequentially. In other words, they operate line by line, one line following the next. That means that the second harvester would not be able to start harvesting its row until the first harvester was finished. And this limits the amount of efficiency we can create by having multiple harvesters. So what we want to know, is there a way to get all these harvesters to work at the same time? And obviously the answer is yes, we can use threads. So how do we do this? Well, first of all, we need to understand what threads are. Every thread is a separate flow of control, or a sequence of statements that runs on its own, independent on the rest of the program or anything else that's happening. So examples of where you might see this. The main method in your program is its own thread. Once you start running that main method, the program starts to execute its code sequentially from beginning to end. If you try and do a print operation on your computer and you print to the printer, that is a separate thread of instructions. All the information is being passed to the printer, which then prints it. And you can do that while doing other things on your computer. Animations would be another example of a thread. So when you animate something to do some sort of spin or twirl or whatever it's going to be on the screen, that often happens independently of the other things that are going on in your program. So these would all be separate threads that would be existing in your code. Now when more than one thread exists at a time, the computer has to switch the execution between one and the other. And statements within a thread are executed in order. So everything still happens in the order that it's seen in the program. The problem is I'm going to be switching from one thread to the next thread. So in one particular thread I might run the first 3 instructions, then go to the second thread and run its first 2 instructions, then go back to the first thread, run an instruction there, back to the second thread, and then as you can see it sort of goes back and forth between the 2 threads, implementing a couple of instructions at a time. This happens so quickly with the processor that it appears as though everything's happening simultaneously, but in fact it's not. It's a couple of instructions from each thread at a time. If you want to use an actual thread in your program, you have to include 2 things. The first is you have to have a constructor for the thread object itself, and then you have to have a command to start the thread. So let's take a look at that first piece, the thread constructor. The constructor for a thread requires an object that's to be run to be passed as a parameter. So let's say I want to have a thread that is going to make a harvest bot run across a screen. That thread constructor here, which I'm going to call harvest bot, is going to be a new thread, and it requires the object that is going to run when my thread starts. And this object in this case is going to be a harvester object. So this harvester object will run on its own. This will make the new thread that will run a harvester object called Smithers. Now once I have that thread created, I need to start it. So I use the thread.start. So in this case it would be harvesterbot.start, and it would start this thread. This start method actually invokes the run method in my harvester class. And inside that run method is going to contain all the code that I want to that harvester or that object to do when it starts running in its own thread. The side effect of this is that it means that the harvester class has to have a run method in it. In fact, any class that is going to be used in a thread has to have a run method in it. So Java needs to be able to be ensured or assured that there is a run method existing inside this class before I try to start using it in a thread. I don't want to make a thread and then find, uh-oh, there's no run method here. So I've got to make sure that there is that run method there. So how do you do that? You do that by using what's called an interface. An interface is basically a list of all the methods and commands that are going to be provided by a class that uses or implements that interface. So essentially it's sort of saying here, in order to use this interface, you must have this method, this method, this method, and so on. Okay? This ensures that any class that implements that interface is going to be working properly. Right? It ensures that everything's there that we're going to need to use it. When the class is compiled, it's checked to make sure that those methods are there, and if not, it won't compile properly and give you an error saying you're missing a particular method that you require. So an interface basically looks exactly the same as a class does. The only difference here is instead of being called a public class, it's now a public interface. And the other difference is inside of that body, I only list the signatures and constants. I don't list any actual code. So they're just empty method signatures and constants that have been declared. Nothing else. There's no actual data or content within there. So the interface for thread objects would look something like this. Public interface runnable, and it means that you have to have a run method present in order to make something runnable. Okay? We don't actually see this code. Haven't written this code. This interface exists in the runnable interface. So in my harvester class that I want to create, because I want to use this in a thread, it has to have at the end of its line of code, and the end of its header there, implements runnable. And then I would place all my harvester code here. So it looks something like this. So here's my threaded harvester. It's going to extend robot, and it's going to implement runnable. The rest of this code is the same. You can see I can harvest a field, I can harvest 2 rows, all those things we created before. Okay? The only difference is I also now have a run method, and that run method is going to allow me to harvest 1 row. So as I said before, the run method basically has any code inside of it that is going to be used to execute the thread, and it can call whatever other methods you need within that class or within any other class that you have to have. So let's take a look at running this code. So there's my class. My harvest task, I've created 5 harvesters. Then I create 5 threads that contain each of those harvesters as their threaded objects. And then I start the individual threads. So if I run this, give it a sec for the lag here. So there's my 6 harvesters, and if I run it, you'll see they look like they're all kind of running at the same time. Okay? Now one last thing here before we go is there are a couple of warnings you have to be aware of when you use threads, because they are seeming amazing, you want to use them all the time, but there's some issues there. The first is that the interaction between the threads is limited. Once I start up a thread, it starts running on its own, and I don't really know exactly when it's going to finish. Okay? So let's say, for example, in my class here, I'm not going to write. Let's say I had a situation where I was going to have all these harvesters pick up a bunch of stuff and then dump them on the final row here, and I have one more harvester here that goes and picks up all the things here. This guy up here would have to wait until these harvest threads are finished their runtime, but they're run separately, independent of the main program. So I'd have to have some code here that sort of makes this thing wait for these to happen. It is doable, but it's more complex and it's beyond the scope of this course, so we're not going to get into it. Just be aware that that's an issue. The second warning has to do with changing the program states, because remember, each thread happens independently, and we switch back and forth. And the processor doesn't always switch back and forth at exactly the same time every time a program is run. So you have to be careful that if the state changes at one point in time, it may cause your whole program to crash. I'll give you an example of what that looks like. So let's say here, I go to check, this robot's going to check that there's a thing here. It's going to say, if it's beside a thing, I want to pick something. So it runs that line of code in a thread. It says, is this a pick thing? Is it there? It says, yes, it's true. Something's there. But then that thread stops, and it goes to a second thread where there's a robot here. It moves forward and picks up a thing. It then switches back to the original thread, and now this robot here, which thinks it's beside something, tries to pick it up, and uh-oh, it's not there anymore. It crashes, and there's an issue. Okay? So you have to be aware that the program states may change in between any particular code from one step to the next step, and that may cause issues with running multiple threads at the same time. That's it. That's all we've got for today. I'll see you in class tomorrow where we can practice what we've learned.